Hello and welcome to Riverbank Railways. And this evening we are going to modify a pico point to improve conductivity and reliability of the engines going across the tracks. So this is how it comes out of the box. This is a medium left Electrofrog point, and to explain it just before we do it, just so everyone knows what we're doing, when you have a point like this you will usually have power connected to the left rail and the right rail. And then depending on which way this is set, this will then carry the power because it's making contact here. It'll carry the power along the rail here. Now the frog, which is this bit, this and this are connected underneath through some wiring here. So whatever polarity this rail is here, this frog will also be. And then obviously when you switch it back, this rail stays positive and this rail here stays negative all the way through. So that's all well and good, but the single flaw is that it relies on the electrical conductivity between the point blades and this piece of metal here, and that's likely to get dirty or dusty or grimy, or if you weather the track you can get paint in there and everything, and if that contact gets dirty, then the electrical conductivity is not as good, and therefore the train can kind of stall and stuff going through the point. So what you can do, and Pico actually have them, the modern ones anyway, they have them pre-made to do this. If you look really closely, you'll see a gap here in the tracks, and underneath there's two little wires connecting that gap. So what that means is, although there's a break in the rail here, the power will go across it because the two little wires underneath are carrying the power. And what we're going to do to improve this is, you'll also see there's another wire here connected underneath, which is going directly into the frog. So whatever we power that wire, that will power this frog. So what you can do is you can attach your own power to the left and the right rail. And if you're using a point motor to switch the point from left to right, and it has a polarity switch on the point motor, you have the option of controlling whether there's positive or negative power going to this wire, which is controlling whether the frog is positive or negative. So you can cut these two wires here, supply power to the rails, and in doing so, if you cut those two wires, this will be dead. But you can bridge these two rails and these two rails, because these will always be negative up as far as the gap. These will always be positive up as far as the gap. And that will mean that these two inner rails will have electricity from your power bus going around. It will not rely on the blades carrying the electricity between them, which means that the power on these rails is independent of these blades, and if they get dirty or dusty or whatever, it's not going to affect them. You then have the problem of, well, if this is broken here, how do we get power to this frog? And that's where our point switch comes in. Our wire, going back to our polarity switch, comes to here, connects in here. So if for example, let's say this rail is positive, if our point switch is set this way, this rail is negative, this rail is positive, this rail in here is positive up as far as there, and our point switch, which is also taking power, will send positive power to our wire here, which will give positive power to this whole frog, resulting in power all the way along the track. And then obviously switch the other way, this rail is positive, this is negative, our point switch is then sending negative power to our rail, which is making the rest of this negative. So that's what we're going to do. So we have a couple of tasks to do. First thing is, we're going to cut these two wires and take them off. We're going to trim this down and attach our own wire on, because this usually goes through a baseboard, and you don't want power going through the baseboard. You just use a wire to be more insulated. And then lastly, they actually very helpfully have missing sleepers here. We're going to solder a wire across these two and across those two to carry the power across, and that'll be it. It seems daunting at the start. The reason I'm making this video is, like, I've only done this a few months, and it seems daunting at the start to do all this, especially as these are probably about, you know, they're £20 sterling or whatever they were. So you don't want to go messing with them unless you know what you're doing. But it's actually quite simple to do. And once you get the hang of it, you know, you do them in about 5 minutes. So we get started. What you need is, put your point upside down here, you can see that. Actually, we don't need to. First thing we're going to do, we're going to take off these two little wires here. And they're only very loosely soldered, so they come off fairly easily enough. There's one. And the other one was a bit stickier, so we'll just cut. There we go. So now our frog is dead, there's no power going across here. We're then going to trim this little wire here, because what I'm going to do is the point motor is going to be down here, so you need a wire to run all the way down here to your point motor. So we're going, and it'll usually be under the baseboard as well. So we're going to trim it down and hold on to that little wire because we're going to need it in a sec. There we go. Now what you need a length of wire, usually about that. I use white wire for my pole RB switches, whatever you normally do. And we're going to solder that here. And then this is going to go down to our point motor underneath the baseboard. So cut off a length of wire and, you know, trim off the end and stuff. And then you need 2 bits of power wire. Again, roughly the same length because it has to go to the point switch. You're going to be trimming it after anyway. And you're going to solder this power wire onto our connections here. And that'll carry power to the point itself. One thing you need to know is which direction or which side you're putting the positive on. So in my layout, if I think about this for a second, this point is going to run like this, and the positive power is on the inside. Yeah, so the positive power needs to go on this side here. So it's on the right. So we'll keep the brown one on the right. I use brown for positive. Okay, so first thing we're going to do is solder on our little wire onto this. And take a bit of solder and a bit of flux on the wire. Hold it against. Yep, good connection there. Now the next thing we're going to do is we're going to bridge this gap with a little bit of wire. So the bit of wire that you cut off from this earlier is perfect for this. And what I do is generally just make a small U shape with it. I'll show you what I mean now. So I'll take a bit of wire, only a small bit, bend it up. You can see that, yeah. Something like that. You can see it. And just check the length. Yep. I'm going to cut off the other bit. Okay, and now we make one for the other side. Try not to lose them when you cut them. I'd say the floor here is littered with a few of these, so. Nope, that's going to be too far. get a bit of flux and put it on those gold pieces. And added benefit of the flux will hold a little piece of wire in place when you try and solder it in. I'll try and bring it up and show you a bit closer. Yeah, I hope you can see that. See our little piece of wire there connecting across. We do the other one. There we go. So we've our two pieces of wire connecting those two rails. I'm going to drop a solder on them. Just a tiny drop, you don't need much. I need to clean that a bit. There we go. So you can just see there. So two pieces of wire soldered across there now. Yeah, last step. Get your wire here and trim it. So on this wire, this is your power wire. You want this kind of sticking directly into your point. And what I usually do is just bend the tip of it a little bit, just to give it kind of more surface area for being in contact with the point. Or sorry, yeah, for being in contact with the solder. Okay, so that's kind of what you're going for there, see? And you can dip that in your flux as well, it'll make it easier. And you should, if you tin this wire, it makes it easier as well. So just tin it up. Because if it has solder on it already, all you have to do is heat it up and the two of them will stick. There we go. So there's solder on the rail, there's solder on the wire. If you heat them up, they'll just stick. You don't have to do anything more than that. Try and make it as straight as possible as well, because you're going to be drilling this into the baseboard. So if you make it at an angle, it makes it harder to adjust the point afterwards. Make sure it's nice and tight as well, because it will get pulled a little when you're drilling into the baseboard, and if it pulls off when you're at that stage, you have to come all the way back and do this again. So now you can see that one. I've bent it, and it's just a little bit too long. It won't fit between the sleepers, so we'll just trim it off. Don't be afraid to give it a good pull on it, because you know, if it comes off, it's just you stick it back, but if it comes off later on, it's trickier. And there we go. Now we do some testing. So hopefully you can see that. So we have our wire at the top here, and then our two power wires. So our power wires obviously are going to carry power. They carry power here and here. The wire that we soldered between them carries power to these two inner rails. The point switch, which will also have power, powers this white wire, which will then power the frog accordingly. And that means you have full electrical contact all across the point, independent of these two blades. And it gives really good running. The difference is amazing. So, how to test this before you put it in to the layout? It's very simple. You get your multimeter out, turn it on, and set it to the diode setting there, so that it can just check conductivity. Obviously, yeah, you need to turn it up the other way as well. So, first thing we're doing is checking the white wire. And I'm not sure if you can see that, but yeah, it's at a 1 there, right? So if there's conductivity, it goes down towards 0. So your white wire should be connected to the whole frog. There's 4 rails on the frog, so we touch the other probe. I'm holding the wire against the probe here. Touch the other probe there, down to 0.0, and the next one. Good, and the next one, and the next one. All good, that's the white wire done. Our brown wire is connected to this rail, so we want to test the brown wire to this rail and to this rail, and then test these 2 rails between them. So we have our brown wire to here, yep, and to here. Very good. I'm getting all tangled up now. And then these 2. Good. And then obviously the same thing on the blue wire. That's cool. Incidentally, this is also how you can test a second-hand point if you buy one, as opposed to using a loco. Just check the conductivity and we're all good. So there you have it. There's modifying the Pico point to improve performance and give you more control over the polarity of the switch here. I hope you enjoyed that. I had to cut out there for a second. There's a lot of videos out there. I didn't know how to do this a few weeks ago, so it's easy enough to pick up. There's a lot of videos for doing single points, and I will do a 3-way one next, because I haven't seen a video for a 3-way, and I've already done one. A little bit more complex. It looks scary at the start, but it's actually not. So we'll do that maybe tomorrow, and I'll put the link into it up in the video here. So hope you enjoyed that. Hope it's useful to you. If you want to like or comment or share, please feel free, and talk to you soon.